Earth's shadow will soon swallow 96% of the moon, giving the Americas a front row seat to a deep partial eclipse. This is Fascinating Frontiers, episode 170. Here is what you may have missed across the past week. NASA has kept multiple efforts moving forward with balloon campaigns and high-lift aircraft testing. Commercial station development continues alongside international momentum in lunar exploration. Both ESA contributions and broader agency coordination remain active in the field. On August 27th to 28th, Earth's shadow will cover 96% of the moon's face during a near-total event. Observers in North and South America will see the longest phase of the eclipse, according to reports from phys.org Space. The geometry places the Americas in the best viewing zone compared with other continents. No total coverage is expected, yet the depth of the partial phase will still darken the lunar disk noticeably. The event follows last month's total solar eclipse and offers another chance to watch Earth's shadow in action. Clear skies across the hemisphere will determine how widely the darkening is observed. Now shifting to Mars, the Curiosity rover has resumed its standard science program after a brief study of an erosional surface. Operations now focus on ascending Mount Sharp with regular instrument checks and imaging. The team at Mela Space Science Systems handled planning for Sols 4982 to 4987. Alison Dries-Padilla, Missions Operations Specialist at Mela Space Science Systems, coordinated the Earth planning dated Friday, August 14, 2024. After the detour, the rover is back on course with no major anomalies reported during the transition. Future drives will continue the climb while collecting new data on the layered terrain. The rover also captured a large area of polygonal patterns on the surface near Mount Sharp. These formations stand out because Mars lacks the plate tectonics, volcanism, and flowing water that reshape Earth's landscapes. The polygons likely record ancient environmental conditions preserved in the regolith. The absence of resurfacing processes leaves these features intact for study. The images add to the record of how the Martian surface has evolved over billions of years. On a different note, researchers tracked synchronized radio pulses from binaries containing a white dwarf and a smaller M-dwarf companion. The compact dead star and its red dwarf partner orbit in a configuration that generates long-period radio emissions. Observations helped clarify why these particular pairs repeat their signals on regular timescales. Data tie the timing of the bursts directly to the binary orbital period. Follow-up monitoring will examine whether the same emission mechanism appears across wider orbital separations. Johnson Space Center is adapting its astronaut training facilities as private companies develop their own orbital platforms. Tours show existing simulators already incorporating hardware from multiple commercial providers. The changes prepare crews for operations that will extend beyond the International Space Station era. Officials are mapping how training timelines will evolve once commercial stations host long-duration missions. The work includes coordination between NASA and industry partners on shared procedures. Images returned by Voyager 2 on August 22, 1989, showed the ice giant possesses a ring system. The discovery came 12 years after launch and marked the final planetary encounter of Voyager 2's primary mission. Ground teams confirmed the rings through multiple camera angles before announcing the finding. The data remain a key reference for models of Neptune's faint ring arcs. The announcement followed the August 20, 1977 launch from Cape Canaveral. Those images continue to inform studies of the outer solar system's smallest ring systems. An astronaut on Expedition 72 photographed the 2025 Prayag Maha Kumbh Mela from orbit using a Nikon Z9. The image shows millions of pilgrims gathered along the sacred riverbanks in India. The event occurs once every 144 years and ranks among the largest temporary assemblies on Earth. The orbital perspective reveals the scale of the gathering in a single wide-field frame. Astro_Petit posted additional photos from the same mission on social platforms. The shot highlights how space-based cameras can document large-scale human activity from hundreds of kilometers above. Typhoon Narra may force China to miss the current launch window for the Chang'e 7 mission to the lunar South Pole. The storm raises the possibility that the lander and its accompanying rover will face delays before departure. Mission planners are monitoring weather conditions closely as the window approaches. Any postponement would affect the timeline for the first detailed survey of the South Polar region. The mission includes a stationary lander, rover, and additional surface instruments. Recent progress shows China ahead in the race to establish sustained operations on the Moon. The United States is taking steps to close the gap, yet the competition remains tight. Multiple Chinese missions have already demonstrated landing and sample return capabilities. Continued launches will determine whether the lead widens or narrows in the coming years. The astronomy picture of the day for August 23 features the Cassini spacecraft nearing Saturn after its long cruise. The image captures the probe's perspective before it entered orbit around the ringed planet. Cassini later provided years of data on the planet's atmosphere, rings, and moons. The historic approach remains a milestone in outer planet exploration. NASA has developed a new high-lift version of the Common Research Model for wind tunnel testing. The updated geometry allows researchers to study aerodynamic performance at takeoff and landing conditions. Data from the model will be stored in a public database once testing concludes. The semi-span test of the CRM-NLF model at NASA's National Transonic Facility evaluated laminar flow across a range of Reynolds and Mach numbers. The campaign refined cryogenic temperature-sensitive paint methods for visualizing boundary layer transition. Results from that run continue to inform current high-speed aerodynamic studies. The first scientific balloon of the Fort Sumner campaign launched at 8:31 a.m. Mountain Daylight Time on August 22 and reached a float altitude of approximately 123,000 feet. The payload flew for 4 hours and 8 minutes before termination. The flight marks the start of a series of missions planned from the New Mexico site. Data from the instruments will support atmospheric and astrophysics investigations. In the early 2000s, NASA sent Salmonella bacteria aboard space shuttle missions to study how microgravity alters microbial behavior. The organisms returned with changes in virulence that researchers had not anticipated before flight. Follow-on ground studies later identified specific genes linked to the increased pathogenicity. The findings prompted new protocols for crew health monitoring on long-duration flights. A single composite image records 9 hours of star trails centered on the southern celestial pole. The photographer used a time-lapse rig to condense an entire night into one frame. Earth's rotation produces the circular star paths around the pole visible in the shot. The image also shows the Milky Way's bright core glowing against the dark sky. Rodrigo Eduardo Muñoz captured the scene with an overnight setup that summarized the full rotation in a single view. White dwarf and red dwarf binaries are turning out to be reliable producers of repeating radio pulses. The compact stellar remnant and its cooler companion orbit so closely that their interaction generates periodic bursts detectable from Earth. Data now tie the timing of these signals directly to the binary period rather than to isolated flare activity. Follow-up radio monitoring will test whether the same mechanism operates across a wider range of orbital separations. The systems offer a natural laboratory for studying magnetized plasma flows under extreme gravitational conditions. A pair of stars locked in a tight orbit can generate radio emission that behaves like a natural laser, repeating with clock-like precision. Picture two objects whose combined mass equals roughly one sun, yet fit inside a volume the size of a large city. The white dwarf's intense gravity pulls material from the red dwarf, creating a magnetized plasma bridge that rotates with the binary. Every time the bridge sweeps across our line of sight, a narrow beam of coherent radio waves reaches us, sometimes from systems thousands of light years away. The pulses can last minutes and repeat on timescales of hours to days, a cadence set by the orbital motion rather than by any internal clock inside either star. One measured system shows the radio beam sweeping past Earth at nearly the speed of light, while the stars themselves orbit at only tens of kilometers per second. Astronomers still cannot explain why the emission stays so narrowly beamed and so stable over years of observation. The same binaries should produce messy, irregular flares, yet the signal remains orderly. The unanswered question is what exact plasma process converts the orbital energy into such a clean, repeating radio laser? Keep an eye on the Chang'e 7 launch status as weather developments unfold over the coming days. That covers today's space and science news. Share this with a fellow space enthusiast if you found it interesting. I'm Patrick in Vancouver. See you tomorrow. And if you'd rather watch than listen, find us on YouTube at Narra Network. Links in the show notes. One more thing. If you liked today's episode, our sister show, Models and Agents for Beginners, is worth a spot in your feed. Artificial Intelligence Explained Simply, for beginners and curious teens. It's one of the Narra Network's daily briefings, all free at narranetwork.com. New to the network? narranetwork.com, start here, picks the right daily briefing for you in about 2 minutes. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.
Drifting softly through